Welcome to Frontline Systems webinar on data mining using XLMiner platform, our advanced product for building predictive models. My name is Dr. Sima Maliki. I am consulting lead and modeling specialist at Frontline Solvers. During the presentation, if you have any questions or comments, please type them into the chat box to be answered at the end as time allows. I strive to remain within the promised time frame, yet to thoroughly cover all the material, sometimes it takes a few minutes longer. I very much appreciate your cooperation. Almost every action in your business generates data. Your sales transactions, customer interactions, even clicks on your website. This data can be a valuable strategic asset when used in your decision making. This is accomplished with data mining. Data mining allows you to find and extract useful information and discover patterns from your large data sets. XLMiner is a powerful tool for you to gain insights from your data via data exploration, visualization, forecasting, and data mining in Excel without any need for programming. And this is a time saver to help you get valuable results quickly. Today, we explore how XLMiner platform can benefit you and how easy it is to use. Together, we'll review typical applications including data analysis with visualization, classification tree, algorithm for classifying wine samples using the boosting Ensemble method, text mining to process and analyze 2 internet news groups, and feature selection. Then we'll forecast using time series smoothing techniques the number of passengers for an airline. To start, let's briefly walk through XLMiner platform features, starting with sampling. Sampling tools in XLMiner enable you to draw a sample of data from virtually any external database, such as Microsoft Access, SQL Server, IBM's DB2, Oracle, and Power Pivot. In our recent release, you can get a sample from Apache Spark Big Data clusters. Furthermore, you can import a sample of text documents from a file folder to mine for insights. Most of you would agree that Excel provides ease and speed for building models, and it is familiar to everyone. You can also use Excel for all your analytic needs, and this permits some synergy by doing them together. And Excel is such a good database client and very powerful. With Microsoft Power Pivot add-in, a full database underneath spreadsheets, you essentially have SQL Server in the memory with Excel. This allows you to apply data mining methods to your large data sets using XLMiner. With Power Query, you can extract, transform, and load data from a huge range of sources, from enterprise on-premise databases to cloud-based public data stores on Windows Azure Data Marketplace. Please note, Power Pivot and Power Query are actually in the box with Excel 2013, and you just have to activate them. Now, let's switch to Excel. Here is the XLMiner platform ribbon you can use to apply the full power of data exploration, visualization, and predictive analytics. The Explore tool allows you to visualize your data and provides you with feature selection capability. With XLMiner Chart Wizard, you can create 8 different types of charts, from the simple bar and line charts to scatter plots to more complex the scatter plot matrices and parallel coordinates. XLMiner offers a complete set of data handling utilities. This includes missing data handling, bin continuous data, transforming categorical data, and principal components analysis. Here is a text mining tool, allowing you to gain insights from your unstructured text data. As you can see, XLMiner contains built-in time series analysis tools. It includes the capability to partition a time series dataset, the ability to fit a model using ARIMA with or without seasonal components, and 4 types of smoothing techniques. In addition, with partition, you can partition your data to training, validation, or test sets using standard partition or partition with oversampling, so a model can be trained and then evaluated. This can be done using this button or the partition on the fly feature, which we will be using today. XLMiner methods include both supervised and unsupervised learning techniques. You can have access to 10 supervised learning techniques, including 6 classification and 4 prediction methods. Furthermore, you can build better classification and prediction models using Ensemble methods that are accessible via cascading menus for regression tree, neural network, and in the classification algorithms for classification tree and neural networks. XLMiner for unsupervised learning algorithms include 2 clustering methods, principal components, and association rules. Now on to visualization. Let's start with opening the wine sample database. To access this example and all other examples, click on Help from XLMiner ribbon and click on Examples. Here, let's click on Forecasting Data Mining Examples. We are going to look at one sample, and if I scroll down, it's here, wine. Let me click on XLMiner ribbon. Here is a dataset with information about wine, including 13 variables that describe different properties of wine from 3 vineyards. Our goal is to assign a wine classification to each record. Let's first use the chart wizard to see what it shows. You can select any cell within the data and click on Explore Chart Wizard. Now let's choose Scatter Plot Matrix. Click on Next. Here I'm going to choose 4 variables: alcohol, flavonoids, this one, and color intensity. Now let's click on Finish. Okay, on the diagonal, we have histogram of our variables, and on either side we have the scatter plots. Let's look at these scatter plots on the top right. If we pay closer attention, we could see a distinct cluster of observation. We can select these data points. We can select the data points in this cluster with our cursor, and I want to show you that they immediately turned red. Not only in this chart, but also in all other charts. Then we can look to the right for details on actual records. For example, if we take a look at type, they seem to be, most of them, they seem to belong to wine type B. And if I want to remove this selection, I just click on the graph. Now, let's use color by feature to see what it can tell us. In the upper right of the graph, there's this drop-down menu, and I'm going to choose the type. We can see that all of the observations that we looked at in that cluster belong to wine type B. This visualization is helpful, but not enough for our purposes to draw a line to classify the records. So I'm going to close this chart, and if you would like to save this chart, you can just give it a name and click Save. And the way to access it is to explore existing charts. So let's move on to building a classifier model which would automatically look at this data and fits a model to indicate which vineyard the wine comes from. Let's use the classification tree algorithm. Select the cell within the data and click on Classify, Classification Tree, and then let's choose Single Tree. So we are going to select type as our output variable. This is the wine type which we are going to assign to each of the records. Then I'm going to select all other variables and click on this button as selected variables. Now we can click on Next. Let's keep all the defaults for maximum number of tree levels and minimum number of records in a terminal node. For more details on all these options, you can refer to XLMiner user guide, which is available through help and then user guides. Now, if you notice, there's this partition data. I'm going to click and check this partition data checkbox, and this is our partition on the fly feature. So I'm going to accept all the defaults and click on Next. Let's choose full to get the full tree, and now click on Finish. Here is the output of the classification tree algorithm. There's this output navigator to allow you to quickly reach to various sections of the output. So let's go to full tree. This is the full tree. And then I want to go to training score summary report. So here we can view the classification confusion matrix. Let me increase the size. As you can see, there was one case misclassified in the training data, resulting in a % error of 0.9, and there were 7 cases misclassified in the validation data, resulting in a % error of 9.8. Now let's compare a single tree results with those from classification tree ensemble boosting method. But just before that, let's go back to our slides and review some information on these algorithms. Ensemble methods can help us build better classification and prediction models. It is a technique for combining multiple weak learners in an attempt to create a strong learner by taking a weighted vote of their individual classifications or predictions. And we have 3 algorithms for choosing weak learners and combining the results. And as we saw before, these ensemble methods are available for both classification and prediction algorithms. Let's go back to our wine data set. I'm going to click on Data tab. Again, select the cell within the data, click on Classify, Classification 3. This time we are going to choose Ensemble Boosting Algorithm. We want to select type as our output variable, but XLMiner automatically recalls and repeats the selected variables. Let's click on Next. We can keep the default selection for boosting algorithm, and you can see that XLMiner offers 3 different variations of boosting. The difference is the way in which the weights assigned to each observation or record are updated. Then I'm going to leave the number of weak learners as the default value of 50. Here, a weak learner is a classification tree. So this will tell XLMiner to construct 50 different classification trees using the during the run, and then train each one on different subsets of data and combine the results to get a better classification. In the tree section, let's keep the default settings. Now let's check the partition data to use the for partition on the fly. And then let's click on next. I'm going to keep the same data, same options, and click on finish. Here's the output of the classification tree boosting ensemble method. Let's go to ensemble details. As you can see, XLMiner assigns a weight to each of the 50 weak learners. And you can see the final weights. The importance percentage for each variable measures the variable's contribution in reducing the total misclassification error. Now let's scroll down to training data scoring summary report to view the classification confusion matrix for both training data and validation data. As you can see, let me increase the size. As you can see, there were no records were misclassified in the training data set, and only 2 records were misclassified in the validation data, resulting in a percent error of 2.8. It is obvious classification tree ensemble methods are very powerful and typically result in better performance than a single tree as we just practiced. Next, let's explore XLMiner. XLMiner text mining tool allows you to process and analyze your unstructured text data so you can quickly and fully utilize the power of this data to enable better decision making. This tool can analyze text found in cells in a worksheet, fields in a database, or in separate text documents. Now, let's start with importing some text documents into Excel. For this example, we use the text files from a well-known text data set which consists of messages collected from 2 different internet news groups, autos and electronics. Let me show you that XLMiner text mining documents is available here in the examples. You can save it and then unzip the folder. I've already unzipped this folder, so I'm just going to start with an empty workbook. And then I want to extract a sample of text files from the file folder. XLMiner can work with text that is in a column in a spreadsheet, or text that is in a column of database, or text that is in a series of files, text files in a folder, and that is what we are going to do here. So on the ribbon, let's choose Get Data, and then choose File Folder. In this dialog, I'm going to use Browse to navigate to where I have that auto subfolder internet news group. So I have it here, and here's the autos folder. Now let's select change the file type to all files. Select all of them and click open. Now if I click on this button, I will move all of them to selected files. Again, I'm going to repeat the same steps for electronic subfolder. Bringing in files into the left list box, then selecting them and getting a sample afterwards. All files, select all of them and click open. Let's select them and move them to the selected files. Okay, now we are ready. I'm going to select the radio button, sample from selected files, and we can enter, for example, 300 for the desired sample size. We can keep the default settings. Okay, in the output section, you can see that right file path is selected. XLMiner can either import the text directly into the spreadsheet if a single document will fit into a single cell. But there are limits on the number of characters per cell, and in this case, XLMiner can just record the file path, which is what we're going to do here. So I'm going to choose write file path and then click OK. And here are the results. So we have imported the text files. This spreadsheet, XLM sample files, includes the file paths, but there's no text as expected. But then during the text mining, we actually read the files at those file paths. And as you can see, the name of this column, including the file paths, is text there. Now we are ready to go to the XLMiner ribbon and click text icon. Now we can select the column text var and move it to selected text variable. Now XLMiner have access to read all the text within all the paths during the analysis. Let's click on next, or you could just directly click on pre-processing. Pre-processing eliminates common words so text mining can focus on the words that carry the most meaning. I'm going to keep all the default settings for stop words, stemming, and case normalization. Again, all this information is available in an XLMiner user guide. Now let's click on next button, or we could just directly click on representation. XLMiner will create a matrix of terms and their frequencies. And if perform latent semantic indexing is checked, XLMiner will extract concepts from a set of documents, where a concept represents a cluster of words that tend to occur together in the text of different documents. Basically, XLMiner counts how many words that are occurring in each document. In latent semantic indexing, we convert that information into a smaller number of concepts. On the Output Options tab, let's choose Concept Document, Term, and then let's choose Term Concept. Then I want to make sure we choose Zips Plot, and then Script Plot, and Terms Scatter Plot. And then let's choose Concept Import. Yes, I think I selected whatever I needed, and then click on Finish to run the text mining analysis. Here are the results. So we see the pop-up charts that appear. Let's move them to the right so you can better see them. I'm going to increase the size. This is Zips plot. It shows the most frequent words, and you can see the typical rapid drop in word frequency. If I hover over my mouse on the right spot, you should be able to see, for example, what term is there, what is the document frequency, and what is the frequent collection frequency. And then if you choose any of the ones here, again, you should see what term or what is the rank. For example, the term is campus, document frequency 6, and so on. And then this is the script plot. A script plot shows the relative importance of extracted concepts. And then this is the term scatter plot. On the x coordinate, we have concept 1, and then on the here we have concept 2. Concept 1 is really a cluster of words. For example, car, drive, system, auto, words that more often found to occur together. You can choose to change the concepts chosen on the axis. For example, here I'm going to select concept 14. And you immediately see the cluster of words migrate over in terms of their frequency toward concept 14. And you can see that this cloud moves. So let's close this chart. This is the TMLSA Cerium worksheet that includes the concept document matrix. The concept which appear in the columns, concept 1, concept 2, concept 3, act like numerical variables in your model, and the rows are typically like documents which are the same as cases or observations. Therefore, this concept document matrix can be used as input to any of XLMiner's clustering, classification, and prediction algorithms. For example, you can use a classification method to create a classification model using the concept document matrix to classify new documents based on the text content, whether they belong to the autos group or the electronics group. We just saw how you can get productive results from text. XLMiner text mining tool can be used to classify customer reviews as satisfied, not satisfied, distinguish between which products has the least negative reviews, extract the topics of articles, cluster the documents, terms, and so on. Now on to feature selection. Feature selection in both XLMiner Pro and Platform helps you identify which of all of the hundreds of your variables or columns of data have the most predictive power to feed into your classification or prediction algorithms. Let's start with opening Boston housing dataset. So I have the examples here. I'm going to open Boston housing. Boston housing dataset includes 14 variables, each describing a census tract within the city of Boston. Imagine that you have 100 variables instead of like 14 like we have here. A lot of these variables are going to overlap each other. Some are going to be important for your analysis, some may not. You can use all of them in your classification or prediction algorithm, but it is not going to be helpful, and it may take a lot of time. Feature selection is a preliminary step like visualization that you can use to quickly find out which variables are most significant and then concentrate the rest of your analysis on those. Let's see how we can do that. So in this data set, cat.medv is a categorical variable derived from MEDV, or the median value of owner-occupied homes. So I'm going to focus on this categorical variable, cat.medv, as our output variable with the goal of later building a classification model using this dataset. Okay, let's click on XLMiner platform and then choose Explore Feature Selection. In this first dialog, initially, we are going to select cat.medv as our output variable and all other variables except MEDV, or median value of unoccupied homes, as our continuous variables. You can confirm that XLMiner recognizes this as a classification task by choosing categorical. Now let's click on Next button. We can choose all statistical filters to compare Welch's F statistic, Fisher score, and also Gini index. Now we can directly click on Output Options. If you select Top Features Table, you can get a report containing only top variables as indicated by this number, and I'm going to actually increase this to 5. Feature importance plus that is automatically selected by default is a graphical representation of variable importance based on the measure selected. And this measure is based on this rank by, and you can see there are options, but we're going to go by the default Welch's test. I think we are ready to click on Finish now to run feature selection for classification. Okay, here is the feature selection importance plot, which ranks the variables in order of importance according to the Welch's test. The top 5 most relevant variables are LSTAT, RM, industry, PT ratio, and tax. Now let's click on Detailed Feature Selection Report. Here we are analyzing the data using several different statistical tests of their importance. By looking at how different variables are ranked according to different tests, we can get an idea whether these variables are consistently showed up as most important or not. Then you can focus on those variables, the important ones, as inputs to your prediction or classification algorithm. For example, let's look at the Welch's test. And here we go based on the biggest magnitude. So you can see that the largest magnitude is LSTAT with 21, and then the next one is RM. We have industry with 10, PT ratio 10, and tax 8, and the rest of them are less than 8. Also another one, for example, the Gini index. Gini index measures a variable's ability to distinguish between classes. The smaller the Gini index, the more relevant the variable. So if I resort by the Gini index from the smallest to largest, we can see that the top most important variables are, again, RM, LSTAT, industry, PT ratio, and tax. So as we saw, we can see that the top 4 or 5 variables for each statistic include LSTAT, industry, PT ratio, and RM, or actually RM and tax. At this point, we already have a lot of useful information about our variables and their relationship to the category called cat.medv variable. We started out with 14 features, and now we know rather quickly that only 5 of them matters the most. Now we can practice creating classification models, yet instead of using all original variables, we can just use the most important ones. Now let's discuss the time series analysis. Time series is a set of observations on a quantitative variable collected at equal time intervals. Stock prices, exchange rates, consumer price index, or unemployment rate are examples of time series. XLMiner includes ARIMA and smoothing methods. Smoothing techniques smooth out random variations in the time series data and reveal underlying trends and patterns. So let's go to Excel example workbook and open air passenger dataset. This dataset contains the monthly totals of international airline passengers from 1949 to 1960. Here we have only time variable and a quantitative variable, which is the number of passengers that is collected over time each month. Let's click on XLMiner platform and first start by using Chart Wizard to explore this airline passengers time series data to see if it can tell us anything. So let's click on Explore Chart Wizard, and then let's choose line chart and click Next. Here I'm going to choose passenger for my variable and click next, and then here we use month and click finish. Let's increase the size. As you can see, this figure suggests that the data is non-stationary. It has a strong upward trend, and also it has a seasonal pattern. Therefore, forecasts of future values for this time series would be more accurate if they reflected this seasonal effect. So let's close this chart. I'm going to discard it. Now we have to partition this data. This time, instead of using the partition on the fly, let's choose the partition button on the ribbon. So month is our time variable, and passengers is our variable in the partition data. Let's accept all default settings and click OK. Here's the data partition workbook. Select the cell within this data and then click on smoothing, and then we're going to use hold winters. 3 additional menu items will appear: multiplicative, additive, and no trend. With no trend in data yet having seasonality, the third hold winters model can be used. During this practice, we use multiplicative method as the visualization of data shows the strong upward trend. Okay, month is our time variable. Now we choose passenger as our selected variable. Now let's enter 12 for the period, as the seasonality in this data set appears every 12 months. And then you can see that number of complete seasons is automatically changed to 7. I'm going to keep default settings for the parameters, and there is an optimize option you can explore, and we are going to produce forecast on validation. And now let's click OK. The mean square error for our training data is 112, about 112. And now let's take a look at the time plots. This is a time plot for training data using the multiplicative model. And as you can see, the forecasted and actual values match up fairly well. Yet, the usefulness of the model in forecasting will depend upon how close the actual and forecasted values are in the time plot of validation set. So let's verify that. Let's scroll to the right. And here's the time plot of validation set. Again, it seems that multiplicative model captures the data very well, as the actual and forecasted values in this time plot match up fairly well too. This shows that our model is a good fit to our data. Now for a final recap. Every action in your business generates data which can be a valuable strategic asset for your decision making. Data mining enables you to find and extract useful information, discover patterns, and gain insights from your data sets, just like we practice today. And this ability to use data intelligently is a vital skill for business analysts. XLMiner gives you all the tools you need to visualize and transform your data in Excel and apply prediction, classification, and affinity analysis methods. XLMiner is just one component of Analytics Solver platform, a complete tool set for your predictive and prescriptive analytics. During this session, we used XLMiner platform. You can get our data mining software as a standalone program such as XLMiner platform or XLMiner Pro. It is also offered within Analytics Solver platform or Analytics Solver Pro. Analytics Solver platform includes forecasting, data mining, simulation, risk analysis, decision trees, and conventional and stochastic optimization for problems of any size. And Analytics Solver Pro is a complete solution for medium-sized problems. Now, you might be asking, what is your next best step? If you haven't yet registered on our website, please do so. It allows you to download a free trial of Analytics Solver platform, which includes XLMiner platform and gives you access to downloadable user guides and example databases. Try this yourself and let us know if you have any questions via live chat, email, or call us at this special number for this webinar attendees. Thank you very much, and now it is time for your questions. And remember, you're always welcome to send any questions or comments to consulting@solver.com, and I will be in contact with you. Thank you so much. I appreciate the opportunity to have shared in this online training with you. Again, you're welcome to send me any questions to consulting@solver.com. We look forward to future webinars with you. Bye for now. Thank you again.